By using the circuit we made in the previous video, we will program a custom LED blink like this siren pattern. If we put the siren pattern in a timeline, it will look like this. It consists of 3 quick flashes with a short pause in between, and then a longer pause before another 3 flashes. The basic actions that Arduino will do are still the same, which are turning the LED on in these times where it is marked by the red dots, and turning the LED off in the times marked by these black dots. For turning off, the rule is easy. Whenever the LED has been on for 80 milliseconds, then turn it off. So if we use the diagram from the previous video, 2 out of the 3 rules are still the same. We will take a closer look on this third rule. There are 2 different lengths of how long the LED needs to be off before it is turned on. To let the Arduino knows which one to be used, we need to add a counter variable, and let's call this flash counter. When t equals 0, we set the counter to be 0 as well. Next, whenever the Arduino turns the LED on, then increase the counter by 1. This counter then will be used by Arduino to determine the appropriate interval. When the counter is less than 3, then the interval will be 70 milliseconds. When it reaches 3, use 300 milliseconds instead. And don't forget to reset the counter to 0 before it goes to the next cycle. So these are the complete rules for the loop. If the LED is off, check the flash counter. If it is less than 3, then the interval is 70 milliseconds. And then it needs to increase the counter after turning the LED on. If it is 3 or larger, then the interval is 300 milliseconds, and it needs to reset the counter after turning it on. You might be wondering why I use the equal or larger than operator. Instead, just simply use the equal operator. This is a common practice in programming. In a very large and complex code, it is always safer to make the rule covers all possible situations, because we may not be aware of some possible change caused by some other functions. Of course, in this simple code, it makes no difference, but for future words, it may be useful to keep that in mind. Now we will take a look of how these rules are implemented in the sketch. This is the implementation of the turning on rule. The if-then-else statement is not the only way to implement a conditional rule. For a simple value assignment, like the value of the interval or the value of the counter, we can also use an operator called conditional operator, which consists of this question mark and a colon symbol. For example, to assign the value of the interval, it checks whether this condition is satisfied or not. If it is a yes, then this will be the value. Otherwise, it will be the alternative value. Also the same with the counter itself. If the counter value is less than 3, after we turn it on, we increase this. Otherwise, we reset this to 0.